Hi, thank you very much for joining us today. Today we're going to walk through the CyberVault automation capabilities that we have for Spectrum Virtualize. In the 842 code, we introduced the Safeguarded Copy function, which if you kind of follow along the diagram, it covers all of our Spectrum Virtualize products, including the SAN volume controller, the flash storage, as well as Storewise, and integrating with our Copy Services Manager replication and Copy Services orchestration tool, we're able to schedule and manage the recovery of safeguarded copies, which reside in the Spectrum Virtualized storage. But what we're going to focus on today are some of the possibilities of performing automation, particularly around event identification and response, and automation of response, particularly recovery and automated backups. So the first approach we're going to take is looking at using Ansible scripts, and I'll touch more on that, our progression of our demo today a little bit later on. But just at a high level, what we're looking at are some sample use cases, particularly the modification of a honeypot file that we're going to place in our environment. And once that event is triggered, we've developed some Ansible automation to take a quiesce safeguarded copy. Now, by default, Copy Services Manager's schedule function just simply takes a crash consistent copy. But we understand that there is going to be a strong desire for some folks to have application consistent, so we are leveraging the capabilities of Ansible to quiesce the database as well as the file system, take the copy, and then also unquiesce and do all this in an automated fashion. And so on the left, you can see how we have some various mechanisms by which we can trigger, and the last of which is a little bit of a teaser of what we're going to cover. In addition to the Ansible scripting, we're going to look at the IBM QRadar product, as well as its accompanying orchestration framework, the SOAR tool. And in fact, this is actually one of the screenshots from the SOAR tool, which is incredibly powerful in that not only does it automate IT processes or functions, but it actually introduces the ability to incorporate human process functions. And again, we'll demonstrate that in detail a little bit later on. And then the last thing that I kind of wanted to cover is that we, with Ansible Automation, have created an entire loop of where we identify an event, we kick off a list of the backups that we've taken within the Spectrum Virtualized environment, and iterate through starting from the most recent copy and run our identification event test against each of those recovery volumes until we identify one that is valid. And then in our particular demonstration, we're going to go straight into restoring that volume back into production. But as you see on the left, there's a number of options, and that's kind of what we really wanted to demonstrate with Ansible is the modularity of it. We can approach it from several different options in terms of events, in terms of event identification of actions, and validation processes. But in our particular example, we're just going to show an end-to-end flow, including the restoration of production, where in most environments that would probably not be automated. So the overall flow of today's demonstration is going to be, again, we're going to start with the Ansible automation that we've developed in lab services, particularly around that entire flow that I mentioned with regards to the recovery, iteration, and restore. We also have another sequence that we're going to demonstrate, as I mentioned in a couple of slides before, that we have that application consistent backup flow. And we're also going to take the opportunity to introduce you to some of the components of the CyberVault functionality in Spectrum Virtualize. But then next, we're going to move on into the IBM product QRadar and its accompanying automation framework SOAR. And we're going to show how we leverage the Ansible play, particularly that application consistent backup, and after a given event, show how we call that particular function. And then lastly, as I mentioned before, we're going to show a human interaction flow that is afforded by the QRadar and SOAR product. So before we launch into the demonstration, and I hand it over to my colleague Tom, let me just briefly describe our lab topology that we're using to run this demo. So the core of this is our FlashSystem 5200 Spectrum Virtualized Storage. And we have a virtual server, or I think it's actually a real. So we have a Linux server that's running our production, representing the production DB2 instance. We also, over here on the right, have a validation server from which we're going to perform our iterative validation process. So from the primary database volume, we have scheduled and manual safeguarded copies from which we take the recovery volume, present to the validation host, and around that, where the magic happens is we also have an Ansible and copy services management server, and surrounding it, we also have our QRadar server and our SOAR server. And with that, I'm going to turn it over to Tom.
Thank you, Jackson. Yes, today we will be going through the Ansible integration with our Copy Service Manager, where we're going to refer to as CSM here. And we're going to be using a honeypot file to trigger the recovery and restoration automation in this demo. We're going to start here with our CSM window. Here you can see that we have a session defined on the FlashSystem, and we have currently 17 backup points that have been taken. If we switch over to the FlashSystems window, we can see the volume group, and you can see that it's backing up that DB2 LUN for the LVS Serve 54, and we have the same points shown here in this window. Moving over to our terminal window, in the upper left, we have the production DB2 server, where we have a LUN present in the upper section. In the middle section, we have it mounted to the opt IBM DB2. And in the bottom, we've got the honeypot file that we're going to be using for our trigger. On the upper right-hand side, we've got the recovery server, which is just a blank server. It does not have any LUNs, file systems, or that honeypot file present at this time. It'll be used in our recovery iterative loop. In the center section, we have the Ansible scripts, and they are going to show us what's going on with Ansible and on the server, and the final result as we progress. And at the very bottom, we have the bad actor window, where we're going to actually simulate the attack on the environment and see the results for the attack conclusion as well. So down here in the bad actor window, I'm in the DB2 directory, and I'm going to list the contents. And while I've hacked this system, I'm wandering around looking at the environment, and I see this DB2 directory, and it's got this emergency recovery file in it. My goal, while I'm in this initial phases of the attack, is to disable the recovery tools that you're going to need during recovery, but to make it look like it's not something that an outside presence has done, so that you will think it's just corruption or an accident and not consider yourself under attack just yet. So if I try to unzip this file with an unzip -L to see what's in it, I can see there's 3 files, some tools, and recovery notes. I'd really like to see what those are and possibly destroy them. There might be some passwords in that recovery file, so I'm going to try unzipping the file now without the -L, and it will show us, it'll unzip so that I can work with those. But the people have thought ahead and it's password protected. And unfortunately, I do not know that password. So I'm just going to hit return to go back to the prompt. And this doesn't stop me though. I have an idea. What I'll actually do is I'm going to overwrite the contents of that file with random garbage from random, except the first 32K, so that the file still looks like it's good. And then I'm going to change the date and time back to the original so that people will not know that it's ever even been tampered with. And so if you watch in the upper left window, the date and timestamp on that file, it's not going to change at all when we run this command, but we will destroy the contents of this file. So let's go ahead and run that command down here now. And now if we try the unzip -L again, you'll see that it still lists the contents. And if we try to unzip the file and this time use the password, and I'll put the password in and hit return, we can see that it did not unzip properly. We got some errors, but the errors look like what could be considered normal file system corruption or an accident. It doesn't necessarily look like an intruder's been in the system just from this information. And if we do another ls-l, we can see that the one file that tried to extract has 0 bytes down on the tools and nothing useful recovered. So I've accomplished my task of destroying your recovery tools if these were your recovery tools. So let's flip back over to the CSM window. And we can see that the most recent backup point ends in 213 there. We're actually going to introduce a bad backup intentionally into the backup stream so that we have a bad record to iterate through, reject, and show that the iterative automated task evaluates properly and finds that it's the second most recent one that we're going to actually want. So if we flip to the terminal center window for Ansible, and we are going to run Ansible sgc quies. And we're going to run this, and this is going to quiesce the database, take a backup that's going to show up in CSM via the CSM server, and then it's going to unquiesce the database. It's connected to the server, it's quiesced the database, it's freezing the file system, it's going to call CSM for a backup point, which it did. It's now unfreezing the file system, resuming DB2, and it gives us a nice message saying that it was backed up properly. So now if we flip back to the CSM window, and we have to flip down here between the recovery backup info and the backup info window to see it. It should pop in. Oh, there it is, 18. So, oh, we need to sort these backwards. Okay, yes, there we go. There's the most recent one, and it was taken just a few seconds ago, and we've incremented up to 18 backups. So now we have the bad point introduced into the backup environment. We are going to go to the Ansible window in the center, and we are actually going to start our demo. We're going to go down to the bad actor window and just do a CD to get out of the directory so that our session doesn't get killed in the demo. And we're going to go back to the center window, and we're going to run Ansible, and this is going to be the validate, recover, restore. There we go. And this is loading up. We're going to see here that it's going to check that file here momentarily. And when it checks it, it's going to see that even though the date and time were changed, the CRC was not. So you can see we are expecting one CRC, and we've detected a different one. We know that something's been tampered with that file. We pull a list of the backups from the CSM server, and you can see the most recent one is the one there ending in 626. We're going to start with that one, and what we're going to do is initially we're going to do a cleanup on the recovery server just in case something was left behind and it wasn't properly cleaned up. And it's going to, there we go, it's going to request a recovery operation on the CSM server. And it's going to map that over to our recovery server. We're bringing the LUN into it. We can see in the upper right-hand corner, we now have a LUN. We now have the IBM DB2 file system mounted, and we have a honeypot file. You'll see that it just failed the CRC check. And so we're going to clean up the recovery server again and prepare for our next iteration in the loop. We're unmapping that DB LUN from the recovery server now. You can see that we're trying the next backup point that ends in 993. Right here in the CSM window. And we're going to see it start bringing it into the the recovery server here and start the database and everything up again. There, it just cleaned up the old LUN in the upper right, and we're just getting ready to start stepping through this second backup point on the recovery server, which I'll refer to as 993. We requested a recovery operation on the CSM server. We're mapping the LUN over to the recovery server. We're going to detect the LUN. You'll see it pop in the upper right. You can see the LUN. We've got the file system, and we have the honeypot file. We're going to check that, and it passes the CRCs at this time. So we now know that this 993 is our most recent good backup. We're going to clean up the recovery server real quick. Unmounting the DB2 file system there. Unmapping the LUN from that server. And terminating the recovery in the CSM server to delete that recovery LUN. And now you can see we're getting ready to start the restore piece. The difference between recovery and restore. Recovery is a copy of the volume used to validate, test against, or do a surgical recovery. The restore is actually going to restore it back to the source volume, overriding what's up in the upper left-hand corner. So as you can see, we are starting with that same 993 backup point, and we're stopping the database in the production database server. We are requesting we unmounted the file system, and we're requesting a restore operation. If you look quickly over at the CSM server, you'll see the detailed status where it's actually running those commands to do the restore, recovering the data back to its original state. And if we flip back to the Ansible one, we can see that it's rescanning the LUN. It's going to mount. We can see it's mounted, and that honeypot file is back up in the upper left corner. It's now doing the CRC check, which passed, and we can see it tells us that we had failed integrity checks, but we found the recovery ID, and the restore was successful, and the integrity restored. So now just to show you there's no smoke and mirrors in the bad actor window. Let's go back, and we're going to cd to /opt IBM DB2. And we'll do it ls-l to see what's here. You can see it cleaned up that tools tar gz. And we're going to actually unzip this file now. And I'll put in that password. And we can see that it inflated those files properly this time. And if we do another ls-l, we can see that those files were restored properly. So we've seen a successful automated recovery and restoration of an SGC backup point for this DB2 server. And that concludes the first segment of our demo.
Thank you so much, Tom, for taking us through a demonstration of how it is possible to use Ansible Automation to create a CyberVault solution around the new Spectrum Virtualized Safeguarded Copy functionality. So this is only meant to be a teaser, not an instructional video. So for those of you interested in pursuing this further, please reach out to IBM Lab Services, the organization to which Tom and I belong. We would love to work with you to craft a solution to meet your needs. Thank you very much.